In the previous video, we learned what stress is in terms of strength of materials. In this video, we will understand one important type of stress called tensile stress, which occurs due to tension load. Let's dive into the topic. First, we will understand what is tension load. Consider a rod as shown in the image, and which has two applied forces at the both ends. So now what will the body do? It tries to pull the body apart. That applied load is called tension load. So, the tension load will be acting normal to the cross-section of the body. This load may be equal or unequal at both ends. Do you know how the tension load reacts to the body? Consider the rod with pull force in the ends. Due to the application of tension load, the material tends to elongate in the direction of the applied load. This increase in length of the material in the direction of applied load is called deformation, which is due to the applied tension load. Let us consider the free body diagram of rod which has two pull forces at the end. How does this tension load react on the rod? To resist the elongation, the material develops an internal resisting force within its cross-section. But how will this happen? Let us take the cross-sectional area A. First, consider the left side sectional area, where the resisting force is acting on the body opposite to the applied load to resist the material from being away from its stability. Similarly, in the right-hand side also, the resisting forces will act in the opposite direction to the applied load. Hence, the body will remain in equilibrium, and no further elongation occurs. But note, this equilibrium will persist only till the elastic limit of the material.
Tensile stress is defined as the resisting force offered by the material per unit cross-sectional area when it is subjected to tension load. Mathematically, tensile stress is equal to the applied force divided by the cross-sectional area. Here, F is the applied tensile force, and A is the cross-sectional area. The unit of tensile stress in the SI system is Newton per square millimeter or Pascal or kilogram per pound per square meter. In practical engineering applications, Newton per millimeter square is commonly used.
For tension stress, we will do one mathematical example in this video for showing the detailed calculation and its effects. Let us consider a rod with diameter of 10 mm subjected to a tensile load of 3000 Newton at the end. Now we will calculate the tension stress through the formula which we saw earlier, where force is divided by the cross-sectional area. This rod will have a cross-sectional area of 78.54 square millimeters. Now the tensile stress developed in the rod will be equal to the applied load of 3000 Newton divided by cross-sectional area of 78.54 square millimeters, which will result in the tension stress of 38.2 Newton per millimeter square.
Let us see the few examples of tension load and the Tesnian stress. Tensile stress occurs in many real-life and engineering applications, such as connecting bolts are in tension when the pull force is applied, and other are like hanging cables, crane wires, tie rods, and aircraft structural members subjected to pulling forces. Let us summarize the key takeaways from this video. Tension load is a pulling load acting on a body. It causes elongation of the material. Tensile stress is equal to load divided by area. For the same load, a smaller cross-sectional area results in higher tensile stress. In the next video, we will study compression load and compressive stress.